Hey guys, so today we're going to do a video about how to find derivatives using the formal definition of a derivative, often called the limit definition. And what it says is it says f prime of x, which this is just another way to say the derivative of f of x. Derivative equals the limit as h approaches 0 of f of x plus h minus f of x divided by h. So pretty much this is like a more long drawn out way to find a derivative. Once you've learned your derivative rules, you're not going to want to do this way anymore, but sometimes you have to for various reasons. So we're going to just go through some examples right now of how to use this definition. So first of all, let's just look at this pretty simple example and let's write our limit. We're going to have limit as h approaches 0. Then it says f of x plus h, and let's be careful to remember that means f of x plus h. Everywhere we see x in this original problem, so just here this time, we need to write x plus h. So it needs to be 20 x plus h and then minus 10. So that's it. So it'll be 20 x plus h minus 10. Then we're going to subtract, remember, f of x, and be careful to put parentheses around the f of x because the minus sign needs to eventually touch all of the parts of f of x. So we got to be careful there. And then all of that is divided by h. Okay, so second step for finding these is often to distribute, because we're going to always have to distribute something to the x plus h. So we're going to be left with 20x plus 20h minus 10, and now I'm going to distribute this negative to both terms, minus 20x minus plus 20 actually, all divided by, or plus 10, I don't know why I said 20, no 2 there, so plus 10, all divided by h. And now is the more fun part where we can cancel everything out. So we have limit as h approaches 0. Let's see what we can cancel. We can cancel 20x with minus 20x, minus 10 with plus 10, and we're left with 20h divided by h. Well, this step's easy enough. We can cancel out the h's and we get limit as h approaches 0 of 20. Well, there's no h to plug into, so that limit is just 20, which means we are left with f prime of x is 20. And that's our final answer. That's what the derivative of 20x minus 10 is. So if you notice, what we did is eventually we always have to get rid of the bottom, the denominator of h, because if we plug in 0, we're just going to get a fraction over 0, and that is what we call indeterminate form. Indeterminate. So we have to do something else. So that's pretty much what we're doing. We're working towards that throughout the process. And this example was simple, but sometimes we get examples like this that are not so simple. But again, the same process remains. So let's start it out just writing limit as h approaches 0. And again, we're just going to write out everything. So it's going to be 2 times x plus h divided by 4x plus h plus 2. Then minus the whole original function, which is 2x over 4x plus 2. And then we have all divided by h. So with problems like this, we need to really just focus on the top at first. So first we're going to distribute everything we can, and we're going to get 2x plus 2h divided by 4x plus 4h plus 2 minus 2x divided by 4x plus 2. Still all divided by this h, but again, we're not going to worry about that bottom yet. We're just going to keep working with the top. We need to get in a little bit better form, and we need to actually do the subtraction. And to subtract fractions, we need a common denominator. So let's try to look at these and figure out what that common denominator will be. We've got 4x plus 4h plus 2, and then we have 4x plus 2. So I know some of you might be thinking, well, we need to multiply this one by 4h, right? Because it doesn't have it. Well, don't be too quick, because these are like two different factors. We can't just multiply this by 4h, because then we would be left with 16xh, which is something this doesn't even have. So we have to treat them both as separate factors, which means this whole thing, top and bottom, needs to be multiplied by 4x plus 4h plus 2. And this bottom, same thing. Then this function needs to be multiplied by the 4x plus 2, because it doesn't have that part in its denominator. So pretty much it just got more complicated. So we're left with 4x plus 2 times 2x plus 2h divided by, well, we can make it a common denominator in a second, so I'll do minus 2x times 4x plus 4h plus 2. Then our denominator now is just 4x plus 4h plus 2 times 4x plus 2. Still all divided by this h. Next step, we're going to need to factor everything out. Well, yeah, FOIL everything, I should say. So it's going to be 8x squared plus 4x plus 8xh plus 4h minus 8x squared minus 8xh minus 4x divided by, now let's factor this out, we're going to get 16x squared plus 16xh plus 8x plus 8x again plus 8h plus 4. So I just factored everything and we still have everything divided by h. And now let's try to combine like terms and cancel things if we can. So looking at this top, I see 8x squared, then I see minus 8x squared, 8 plus 8xh minus 8xh minus 4x plus 4x. Okay, well that cancels out pretty well, so I'm left with limit as h approaches 0. And all I have on the top now is this 4h. So that's looking good. We're getting closer. Divided by, still got a lot down here, 16x squared plus 16xh plus 16x plus 8h plus 4. Still all divided by h. Okay, well what I'm going to do is I'm going to do a final step with the bottom. I'm going to factor out a 4 because I see that that can come out. And I'm going to be left with 4 divided by 4 times 4x squared plus 4xh plus 4x plus 2 plus 1. Well, plus 2h. Oops. Okay, and then all of this still is divided by h. And now is the time that we can work with that h. We've got to get rid of that in the denominator. So I'm going to multiply both sides by 1 over h, both top and bottom, I should say. And I'll be left with limit as h approaches 0 of 4h divided by, we already have 4 out here, now we have 4h on the outside. And then this whole thing on the inside, 4x squared plus 4xh plus 4x plus 2h plus 1. And now we can finally do this cancel that we needed so bad. And we're going to get 1 divided by 4x squared plus 4xh plus 4x plus 2h plus 1. And now we can finally do what we wanted to do all along. Substitute in that 0. We'll get anything that has an h on it is just going to become nothing. So 4xh is just 0. 2h is just 0. So limit as h approaches 0 of 1 over 4x squared plus 4x plus 1. And that is what f prime of x is. So f prime of x is just that right there. 1 divided by 4x squared plus 4x. I don't know why I said 4h plus 4x. We canceled out the h because it was 0. So plus 4x plus 1. And that is our derivative. So again, notice the process was the same. However, it took so much longer because it was division. And that's where our rules are going to help. We're not going to have to do this every time. It takes way too long. But notice that again, we just had to get rid of that denominator, and once that happened, it was easy from there. So thanks for watching. Let me know if you have any questions.